Good afternoon, everybody. So, as Ali mentioned, I'm going to talk about redundant encoding and packaging of live segmented media. This is, don't be shocked, but this will be MPEG part 9. So that's interesting. So yeah, this joint work actually with Ali and Mohammed Raad. So we've been doing some work on this. So I'm just going to try to give you some overview so that you can understand what this is about. So some pointers were already given in Mikael's presentation about encoder synchronization. So the thing that we're trying to address is basically using multiple distribution encoders and multiple packagers or origins. And this can enable various use cases like redundancy for failover. In some cases, one encoder and another encoder could do an A and a B representation for watermarking, and you do the watermarking at the edge. In some cases, you have third-party metadata from a different source that needs to be aligned or synced. And in addition, also, we look at some other topics, including like the cloud storage of live archives. So that's also some of the context. So to get a better overview of like the problems in the industry, in 2021, we organized an online workshop where some of the topics were discussed. It had around 100 participants. The link of the workshop is still online. So we discussed about both redundant live encoding, but also the problem of redundant packaging and having multiple origins. And then also we discussed a bit about live media ingest, which is basically pushing content from the encoder to the origin or from the encoder to the packager. And as we progress the standards work, we're actually planning to have another online workshop in July this year. More about that later. So the third part of the REAP history is the MPEG standardization. So basically, based on the feedback from this workshop, we went through the MPEG process to define use cases and requirements, and there was a call for proposal in 2022, January 22, which had a few responses, including one from the -IF with several companies. And from that response, basically the -IF live media ingest with CMAF was kind of used as a starting point. And currently the document is in the CD stage, going to this draft, it's actually in draft DIS now at the moment. So it's an ideal time to actually review and to provide comments. So I provide here the QR code to both the use case and requirement and the committee draft text. So what is the intention of REAP? So this is like the intended workflow, which many of you will have encountered that basically do media distribution. So in this case, we have multiple distribution encoders, multiple packagers, one or more origins. And then I will come back in not the next slide, but the slide after that on the assumptions. But the idea is to standardize some of the interfaces in the workflow so that basically to the benefit of companies, vendors that are implementing or stuff like ourselves, or also for distributors to have an understanding how they can create these kind of workflows. So in the next slide, I'm going to talk a little bit about the goals of REAP. So I just showed kind of the workflow with the multiple encoders, multiple origins, multiple packagers. So the real idea is to have both a standardized live media ingest, which actually a lot of work was already done on -IF. But the key idea is to create interchangeable elements so that basically it doesn't matter whether you get a segment from encoder A or encoder B or origin A or origin B, and the same for the MPD or the playlist, to have interchangeability, so to avoid these race conditions that you could have in redundant workflows, or if there is inconsistency between encoders or packagers, that can all create problems. Then there's also some effort done on enabling efficient cloud storage, especially of live archives of segmented media. Then another use case is like failover. So I will show later that basically based on the formats that we define, we enable easy rejoining or graceful failure of components. So basically encoders or packagers can fail and join again. And then, as you know, in many workflows, it's very important to support DRM in the workflow or to support dynamic ad insertion. And then also something that's becoming more popular is the mixing of file and live inputs. So we had some contributions and updates on that in the last MPEG meeting. Okay, so I think, just before I continue, I just want to mention a little bit about the assumptions. So there are some assumptions in this workflow. The main thing is that the different distribution encoders will get a common contribution signal, which includes some timing information. And then the trick that we do is we use that timing information to enable basically mapping frames to Unix epoch relative timestamps. And then, so basically we use that to synchronize or at least align media segments, but the requirements for actual system clock synchronization of the different distributed entities is quite loose. So really the idea is to enable the interchangeable media segments and the interchangeable playlists, but it's actually not a full synchronization spec in the sense that we are really trying that it requires any tight time synchronization. It's really on the media timings that matter. So the system clock synchronization requirement is loose. Then how we solve some of the issues is by the cross transmission. So we can basically have multiple distribution encoders pushing to a packager or an origin, so that if one fails, that you can get the segments from the redundant encoder. And then just to be clear, as we're doing this project now in MPEG, so before there was this preceding project in -IF, we really want to focus on the file format and the dash XML formatting. So this is not a complete protocol that we are doing. There is still some flexibility on that because, yeah, MPEG is not the best. MPEG specifies some protocols, but this is not the key strength. I think the key strength of MPEG is to specify, MP4 related formats and, other format-based basically. So yeah, this is basically a spec that really targets the entire OTT workflow from distributed encoder to packager to origin, and also actually there may also be some requirements on the players. Okay, so I'm just going to give a quick overview of then what are the contributions of REAP. So what you can see in the spec, it's first we define the IMPD, which is basically a usage. It's a dash MPD. It's a constraint dash MPD. But it's basically when you want to use an MPD to announce in advance that you're going to send streams. So in the MPD, for example, you have this construct of segment template with segment timeline. For example, you can use that to define like what your post URIs or your put URIs would be. Then there is the REAP track format and segmentation strategy. So this is basically some additional constraints to what already exists in Dash and in Common Media Application format. The main thing that we add is that we specify that we use a common anchor for the different tracks, which is actually based on the Unix epoch, which is the 11-1970, excluding leap seconds. And then there is also a segmentation strategy, so that basically the different distribution encoders can produce aligned segments. So that's an important contribution of the spec. And then there is also the DMPD, which is basically an MPEG dash MPD, and we also have some constraint on how you generate the HLS playlist. But those are basically constraints to be able to generate these MPDs from different packagers that can be interchangeable. So that's really what it's about. So here I give a little bit more detail on the example workflow. So here we have multiple distribution encoders. So in the spec there is this epoch. So in the end, we decided to use the common epoch of Unix epoch, basically. But there is this STS that can be used to map the input timing back to the Unix epoch relative timing, and there is D, which is basically a segment duration. So we assume that encoders will generate constant duration segments. There are some exceptions to that, mainly for DAI, enabling DAI. And then it goes to origin packagers. They are here combined for simplicity, and then you create DMPDs that can be played back and interchangeably from different players. So here is an example of what the IMPD does. So the IMPD is, for example, used for live ingest. So you basically post the IMPD, that contains like the segment template, but it may also contain some information on how to retrieve encryption keys or decrypting the stream. That's all based on Dash. And after that, you can start pushing your segments from your distribution encoder. And then the packager origin is responsible for creating the DMPD. So with regard to the track format, so the main point is that we use this epoch relative timing, but due to combining both the epoch relative timing and the segmentation strategy, basically encoders that join or fail and that want to join again can easily compute based on calculating the number of segments since epoch, what segment they need to produce, and can start buffering the frames and encode the segments again and keep pushing. In the end, a REAP track is in essence a CMAF track. It's just that there is some additional constraint on how you segment it and that you use the Unix epoch as a time anchor. This is actually a concept that's been shown before by encoder companies, including AWS, the epoch locking, they call it. So this is actually a known strategy. So that's, then the other contribution is the DMPD. So this is mainly targeting the issue when you have different packagers or origins creating MPDs, and then players may get confused if they first request an MPD from one origin and then later from another origin. So basically the spec defines some ways how we can use that timing to avoid these issues. So I think I'm running a bit low on time, so I'm not gonna provide all the details, but that's basically in the spec, like some strategies of how to do the packaging from CMAF to HLS or Dash. Then there is some work on the storage. So there is two main contributions. So first, you can use Dash for storage. This is something that is sometimes overlooked. In REAP, we did some additional work on storing live archive in cloud storage, such as object-based storage, where you often can store only one object every time. So there is some issue there with you cannot really append to an object in the cloud. So we basically use the Dash pack and the file format to make that a bit smarter. And then there is also the addition of track identifiers, which are basically some constructs that you can add in the CMAF track to provide additional information, like where the track belongs in terms of the Dash presentation and so on, that can be useful for storage. Then, of course, I don't want to go here without having a demo. So this is one of the demo that we set up. We implemented some of the REAP in FFmpeg, and we push with two different encoders, different bit rates. In this case, the higher bit rate is based on one Docker container, and the lower bit rate is based on another Docker container. So you can see in the demo basically that when you switch from the higher to the lower bit rate, that the stream comes from another container, but the timing is continuous. So there is a printed clock timing in it. Okay. So as I mentioned, we plan to do another workshop in July this year to basically show some more of the spec to get a bit broader feedback from outside of the MPEG community, the same as we did two years ago. I invite everybody interested to join the mailing list and also to work on prototyping and reviewing. So this is basically the presentation. So the standard, the ISO standard, which will be MPEG Part 9, is expected in 2024. So yeah, I think I presented most of it, so I'm not gonna fully go over it. But I do want to acknowledge everybody that contributed to this work from the standardization bodies, both -IF and MPEG. And also my colleague Jamie Fletcher, who did a lot of work on the demo and making it available. So thank you also to everyone here for listening to my talk.